section 6.5, integration. We've got a fair few examples to go through, so let's get moving. So there's 4 results in the formula booklet. You've got the integral of sinh is cosh, not surprising because cosh differentiates to sinh. Integral of cosh is sinh, again for the same reason. Then r sinh differentiates to 1 over square root of 1 plus x squared. So if you undo that, antiderivative, which is integration of 1 over root 1 plus x squared, is r sinh. And then the last one is r cosh. Just as a reminder, you should remember from the section on integrating inverse trig functions that you also have 1 over 1 plus x squared integrates to arctan, and 1 over square root of 1 minus x squared to arcsine. So they're all different. You could see, just need to carefully look what's in the denominator, and then you'll know which function you're dealing with. Okay, so let's have a go at example 23. So this is really simple. Cosh integrates to sinh. If it's 4x minus 1 in brackets, that means you need to divide by 4. Coefficient of x, 4x minus 1 differentiates to 4. That's why you're dividing it. So a quick chain rule can be applied here. So sinh 4x minus 1, a quarter of it, plus c. Over here, you've seen that before when we did inverse trig functions. We have to separate the fraction into 2 separate subfractions. So you've got 2 over x squared plus 1 square rooted and 5x over the same denominator. We're going to find the integral of that. So over here you've got 2 over x squared plus 1. So if you look in the list, it's 1 plus x squared. It will go to r sinh, but you've got 2. So the first one will go to 2 r sinh x plus. Now the second part, let's just do a little bit of work on this. So I'll do it over here. You can do it quickly if you're good at this, but I would always recommend being extra careful. So I want to use substitution. So if I'm trying to find the integral, let's call it I, 5x over square root of x squared plus 1. So I'm going to replace the bit with gets the awkward power. So if you were to bring it to the top, x squared plus 1 would be raised to the power minus a half. So I want to replace it with u. Du is going to be 2x dx. Notice I straight away separated du dx like this because what do I have? Pause for a second to check. I have got x dx here. So that here can be equal to a half du. So if you move that 2 across, let's just do the substituting. So I've got 5 over 2, 5 times a half, bring it to the front. And then you've got 1 over square root of u du. So this is u to the power of minus a half, add 1 to the power, divide by that power, you'll be left with 5 square root of u, which is 5 square root of x squared plus 1. So it's 5 square root of x squared plus 1 plus c. Okay, let's move on to example 25. Again, what you could notice, do it by inspection. You could see that you've got sine 2x is what cosh 2x, well, it's a multiple of what cosh 2x differentiates to. So I'm going to do it by substitution, but you may choose to do it by inspection. Make sure that you don't mess up the amount because you don't have the cosh 2x differentiates to 2 cosh 2x, 2 sinh 2x, but you've got only 1, so you've got a half of that derivative, so you could adjust the amount. So I'm guessing it's going to be a half of whatever. Well, let's see, whatever we're going to get. I prefer to do it with substitution. So let's replace cosh, so the bit with the higher power. You want to keep the derivative unchanged. That will go to cosh 2x. So du dx is 2 sinh 2x. I'll put the dx straight away on that side, and this is the bit I was saying that we have. So that means that I've got a half du here again. So my integral is going to be cosh will become cosh cosh will become u squared, and then you've got a half du. So you add 1 to the power, divide by that power, so it's going to be u cubed over 2, so 1/6 of u cubed. So it's going to be 1/6 of cosh cubed 2x plus c. It's always a good idea actually to check whether you are right. Let me just check. So over here, if I differentiate it, it will go to 1/6 times 3. Then you'll have times 2 from this, and that goes to cosh squared 2x, and then sinh 2x. So that nicely cancels. You've got 1 over 1 cosh squared 2x sinh. So checked. Okay. Good. Let's move on to example 26. Sorry, 25. We're still at example 25, but it's part B. So with tanh, this is the same trick that you need to do if you ever need to prove the result for tan x. So rewrite tanh as sinh x over cosh x. And again, I will do it by substitution. So imagine the denominator being brought to the top. That denominator will get an awkward power. So this is the one you really want to substitute. So let's use u is equal to cosh x. So du dx is sinh x. But I'm moving my dx straight away. And you can see that I have got sinh dx, and this is sinh dx here. So that is completely du. So our integral will become du over u, and that is ln u. But I just need to write ln. I don't need modulus anymore because cosh will never be negative. Remember, cosh is at the lowest equal to 1, so you don't need the modulus symbols. There you go. Okay, so now we're going to move on to example 26. So here, cosh squared 3x. Again, think, what would you do if it was trig function cos squared 3x? Well, you would go to a double angle formula. So we are going to find cosh double that angle, so 2 lots of 3x, which is 6x. That's going to be equal to 2 cosh squared 3x minus 1, exactly the same as if you were dealing with trig functions, because it's cosh, so no change of sign. So that gives me the replacement for cosh squared 3x. So minus 1 goes across, so you've got cosh 6x, add 1, and you divide it by 2, so it's a half of cosh 6x plus 1. So we've got to now integrate a half of cosh 6x, sorry, put that in brackets, plus 1 that's rubbish. Hold on, what have I done? I've tidied it up, and I've that was fine. Okay, let me just rewrite it, because that was fine to begin with. I just suddenly started. So cosh, it's going to be cosh 6x plus 1. Let me just write that 1 plus cosh 6x, so don't get muddled up again. So I don't know what happened there. Okay, so oh yeah, I've got this extra bracket unnecessary. All right, that's better. Okay, so this becomes quite easy. Cosh goes to sinh. You need to divide by 6. So you've got 1/6 of sinh 6x, plus that goes to x. So multiply it out, you've got 1/12 sinh 6x plus a half of x plus c. Okay, so we're going to move on to part B, which is sinh cubed x dx. So I believe we've done this one already. Okay, so first of all, we split this. This is the same trick as with trig functions. So sine cubed or cos cubed, you do the same thing. So you split it into two functions, the product of two functions, one sinh squared, one sinh x. Now this one here needs to be replaced with cos squared. So remember, the identity is cos squared x minus sinh squared x is equal to 1. So sinh squared can be replaced with, let me just rewrite it. So sinh squared is going to be cos squared minus 1. There you go. You may wish to expand it, or you don't need to. I'll expand it. So you can do a complete substitution here, or I'm just going to go for substituting for u is equal to cos u, so the one with the power. Sinh x, if you think about it, you can just integrate it separately. So I'm just going to carry out my substitution to this part, although I could have actually kept it like this and do the substituting here. Will lead to the same result. So cos u is equal to u. So du is going to be sinh x dx. So I have got sinh x dx, and then I've got to do u squared du, and this one I'm just going to put, that will go to cos x. Okay, I'll sort out plus c and make sure all is in terms of x in a minute. That goes to a third u cubed, and this is a third cos cubed u minus cos u plus c. As long as you remember to put plus c in the final line of your answer, that's fine. Okay, so whizzing through these, let's move on to example 27. And I seem to have, I need to write it down again. Okay, example 27, we've got to integrate e to the power of 2x sinh x dx. So you have more than one ways of doing it. You might think this is the product of two functions. How would you do it if it was a trig function? You would do by parts twice and then rearrange. But with this one you don't need to do it, because sinh is e to the power of x minus e to the power of minus x. So you could see that you can actually multiply it out and get to the answer a lot quicker. So e to the power of 2x, and replace your sinh with e to the power of x minus e to the power of x. It will be over 2, so I'll bring that half out. So it's a half e to the power of 3x minus e to the power of x dx. Let's do it, the integration. So this one will go to 1/3 x, and this one will go to itself. What, 1/3 of e to the power of 3x, not x. Okay, so let's just factorize that third out to become 1/6. So this one here, you need to create that third. So you take that third out, you have 3 e to the power of x left plus c. You could even, just to show, you could take e to the power of x out as well, just so you see that it can be done, what it would look like if there's a need for that. Okay, but technically speaking, once you get there, you have got an answer. Okay, so example 28. So here it's a bit of a weird question. It says use appropriate substitution, find the answer to this integral. So over here you could see that x squared minus 1, so if a was 1, it would go to r cosh. So what would be a good substitution? Well, a good substitution would be actually well, it wouldn't just cosh, okay? Because what you want to do here, you want to create this, you don't want this a in the denominator. So because you've got more than that formula in the formula booklet, you've got the other two. So rather than ones, you've got the ones with a's. If you look at this one, you've got x squared minus a squared. So they give you the answer and it gives you a hint as to what to use as your substitution. So you knew that r cosh would be a good one. Now you've got it perfectly. So we're going to use u is equal to r cosh x over a. So you've seen us do it with a trig function, so this is a similar idea. So look in the formula booklet, which of these with a's really you want to be looking at, you are going to use, and then use the answer as your substitution. So that means cosh u is equal to x over a. So let's differentiate it. You have sinh u, and you will have dx over a. And you will have, let's just differentiate it. Actually, let me just, yeah, that's fine. Dx du over 1a. Or should have brought that a out. Let me just do that. So, right, let's start again. So you could do dx du here, and then a sinh u. There you go. Move the du across, and you've got a perfect substitution for dx. So that's your dx. So you add your integral, let's call it I. You've got dx is a sinh u du. In the denominator, I'll have x squared minus a squared. My x is a cosh u. So it's a squared cosh squared u minus a squared. So you've got a sinh u du over a square root of cosh squared u minus 1. Okay, remember the identity. Let me just jot it down so we're clear here that we are using. It's cosh squared u minus sinh squared u is equal to 1. So that means cosh squared minus 1 is equal to sinh u. So you've got a sinh u on the bottom and a over sinh squared u. Okay, you trust me, this is going to be 1 over 1. I think it's obvious, don't need to write u if you want to write another line with that square rooted. Okay, so you are going to integrate 1, which gives you u, which gives you r cosh x over a plus c. Okay, so hopefully you've got enough room to do example 29 on this piece of paper. If not, we'll just have to use another. Okay, so I've already shown you that these two are in the formula booklet. Okay, so we've got to use one of those to answer our question in example 29. So you're going to use x squared minus a squared, so the one that we've just proven. So your a squared here is 16, giving my a is equal to 4. So you can just state the result. It's going to be r cosh. And we're going to use 4 over, so x over 4. And the limits are 5 and 8. Okay, so let's pop the answers in. It's going to be r cosh 8 over 4 minus r cosh 5/4. If you cast back to the start of the chapter, you've learned that r cosh x can be found by applying the formula again. This is in the formula booklet. Now x squared minus 1, it's x squared plus 1 for our sinh. Just be careful, if you were to solve cosh, so let's say if you're solving cosh x equals to 5 and then you applied r cosh, then you will have two solutions. But here, because we are already dealing with r cosh, so you've got only go for this positive answer. So you're going to use ln. 8/4 is 2, so it's going to be 2 plus 2 squared minus 1, the square root of 3, minus ln 5/4 plus 5 squared minus 4, let's just do this one squared, 25/16 minus 1. So it's ln 2 plus root 3. Keep it in brackets, don't forget brackets. I know when you do it fast you may forget. This one is 9/, put it in the calculator, that will give me 3/4, so it's 8/4, so it's going to be 2. So it's ln 2 plus root 3/2. There you go. It was actually show that question, which I didn't put down. So shown. Write a little conclusion, do a tick, hashtag, QED, something like that. Okay, so we've got example 30. We've got to show that the following integrates to this one. So it doesn't give you any hints as to what method to use. So you just need to practice it, and you could see the r sinh. So I'm going to try and use the substitution u equals to r sinh x. Which gives me x is equal to sinh u. That's what I'm going to try. If it doesn't work, then we need to try something else and maybe adapt the amount. So dx du is equal to cosh u. So dx can be replaced with cosh u du. Okay, so I've got the replacement for dx. So now my integral is going to be, you've got 1 plus x squared, so it's 1 plus sinh squared u square rooted, and then times cosh u du. Just remind yourself of the identity that we must use here. So remember, the identity was cosh squared u minus sinh squared u equals 1. We move that across. Cosh squared u is sinh squared u plus 1, which we've got. Okay, so that means I have got, if I square root it, there you go, I've got cosh u. So I've got cosh u times cosh u. So that is cosh squared u du. And how would you integrate cos squared? You would go for cos 2u. So here we are going to go for cosh 2u and replace it with cosh squared u, even two of them, minus 1. So you're going to get cosh squared u is equal to a half of cosh 2u plus 1. So you've got a half, you have cosh 2u, you've got plus 1. So that will go to a half, you've got a half sinh 2u plus u. So bring a quarter out, so let's give it 2/2. So you've got a quarter, you've got sinh. Actually, I don't need to do a quarter, but never mind, I'll sort that in a minute. 2u plus 2u. I'll have to multiply it out because of the way the answer is. So now, if I've got to replace u is equal to, where's my substitution? U is equal to R sinh. Okay, but what about sinh 2u? So sinh 2u is equal to 2 sinh u cos u. Now sinh u can be replaced with x, so I've got 2x. Now cos u is 1 plus sinh squared, so it's going to be 1 plus sinh squared u, so it's 2x square root of 1 plus x squared. Let's do the replacing. I'm multiplying it by a quarter straight away because I didn't need to factorize it. So a quarter times 2x square root of 1 plus x squared, plus a quarter times 2 is a half multiplied by my u is R sinh. Okay, so just finally tidy up this and move the half R sinh x to the front, and you've got a half x square root of 1 plus x squared plus c. Perfect. Okay, so do have a go at this kind of example. Do it a few times in case it crops up in your exam. Moving on to example 31, we've got to use appropriate hyperbolic substitution now to find this integral. Now if you look at your list that is in the formula booklet, you go for one that's got x squared plus a squared square rooted in the denominator. So I suggest you use the appropriate substitution u equals to R sinh x over a, where a is going to be equal to, well, a squared is 9, so a is 3. So let u be equal to R sinh x over 3. So that gives me sinh u is equal to x over 3, so 3 sinh u is equal to x. Dx du is equal to 3 cos u, so dx may be replaced with 3 cos u dx. Okay, so x cubed is going to be 3 sinh cubed u. I will deal with the limits at the end. So x cubed is going to be 27 sinh cubed u. Now square root of x squared plus 9 is going to be square root of 9 sinh squared u plus 9. Taking the 9 out and square rooting gives me 3, and you've got sinh squared u plus 1. And remember the identities are, you've got cos squared u minus sinh squared u is equal to 1. So cos squared u is sinh squared u plus 1. So this is 3 cos u. So we've got 3 cos u, and then dx is replaced with 3 cos u as well. Okay, so those two will nicely cancel, and you've got 27 sinh cubed u du. Okay, so how do we do this? We can do it in the similar way as we did before. Let me do that part in red. So you are going to first of all split sinh into sinh squared u and then sinh u du. This here is going to be cos squared u minus 1. And then I'm afraid we've got to use substitution again. So we are going to replace, we've used u as well, so let's call it v or t. Let's do v is equal to cos u, so the one with the power that needs to be replaced. So dv du is equal to sinh u. So if I put dvu at the end, you've got that part here. So if I highlight this, this here replaces my sinh u, so dv replaces sinh u du, and you've got to integrate 27 of u, no, we called it v squared minus 1 dv. So it's going to be 27 and then a third minus v, a third v cubed minus v. Okay, so what I could do here is work out the limits, work out what v's are when x's are equal to 0 and 6, but I'm just going to return to my cosh u first. So it's 27, and you've got a third of cosh cubed u minus cosh u, and then maybe do the limits now. Okay, so what are my limits? So new limits. So at the moment my x is equal to 0 on the bottom. That x is simply 3 sinh u. So sinh 3 sinh u is equal to 0. That is for u is equal to 0. And then you've got x is equal to 6. So you've got 3 sinh u is equal to 6. So sinh u is equal to 2, which is u is going to be r sinh 2. Okay, so let's now find what we are dealing with. So at the moment I know that sinh u is equal to 2 on the top. I'm dealing with the top limit. Now if you want exact answers, what you want to do is work out what cosh u is if sinh u is 2. So if cosh squared u, using our identity from before, which is over here, that is equal to sinh squared u plus 1. So if sinh is equal to 2, that means 4 plus 1, which is 5. So cosh u must be square root of 5. Remember, cosh, you can only take positive answer. So I think you are happy. We are happy now to evaluate this expression. So let me just put the arrows. Okay, so you're going to have 27 times a third times, we said at the top here, cosh u is worth root 5. So it's going to be root 5 cubed minus root 5 minus 27, and the cosh u, oh, I didn't do that. So u is equal to 0, so cosh 0, oh yeah, let's just write it like this, a third of cosh cubed 0 minus cosh 0. Okay, so let's just tidy this one up. That's going to be 5/3 minus 1, so that will give you 2/3. Do it with a calculator as usual. I forgot my calculator. And then minus 27, cosh 0 is 1, so that's going to be a third minus 1. So what have we got? We've got, we could, yeah, cancel those. Okay, so it's 27 over 3. This is going to be 9 times 2 root 5 minus, this is going to be 1/3 minus 3/3, so minus 2/3, so plus 2/3. So it's going to be 9 times 2. We can maybe factorize 18. Root 5 plus 1. But by all means, pop this into the calculator and hopefully you'll get a nice exact answer. Okay, let's move on to example 31, which I thought I got it prepared here. No, 32, which I don't. Okay, let's just jot it down. Right, so example 32, we've just been asked to find this integral. When you look under the square root over here, you've got a quadratic. Now, the only time you've got a square root and like one on the top, or a number constant on the top, is going to be either arcsinh or arccos or arcsine or arcsinh, you know, with a obviously. It's not going to be arcsine because it's minus x squared, and here we've got positive, so it's it will be either arcsinh or arccos. Let's have a look which one we're talking about. So let's have a look. The thing to do here, we've got to make it into a perfect square, so we've got to complete the square. So 2x squared plus 12x. Let's complete the square. So take the 2 out, and then you've got x squared plus 6x. This will give me 2, and then you've got x plus 3 squared minus 9. There you go. So we can replace 1 over square root of this with square root of 2, and then you've got times x plus 3 squared minus 9. So this is here. What I want to do is be able to use clearly going to be this one, x squared minus a squared, in a clever way. So first of all, let's get rid of that root 2, and then you've got square root of x plus 3 squared minus 9. There you go. Okay, so what have we got here? We've got to find out what is the value of a. The fact that rather than x we've got a linear bracket, that's not a problem, because as soon it's like an inside function. If that inside function has been swapped into a linear expression, you will just need to adjust the integral by dividing by the coefficient of x. So do a quick inverse of the chain rule. So over here, rather than x, we've got x plus 3. That's okay. Our a squared is equal to 9, so a is equal to 3. Okay, so this here is going to be equal to, we're going to take the 1 over root 2 out, and then we've got 1 over square root of x plus 3 squared minus 9 dx. So if a is equal to 3, I'm reading from arccos, it's got to be simply arccos. Rather than x, we've got x plus 3. I do not need to divide by any different number. I am dividing by 1 because the coefficient of x is 1, or this differentiates to 1, so should be dividing by that. Don't need to. But the value of a is 3, so it's over 3 plus c. There you go. I don't think it had limits. Let me just double check. Yeah, that's it. There you go. Okay. So if you are worried that you can't spot this, what the textbook did, so I better talk about it as well. So if you are thinking it might, you know, this complicated part here need to be replaced, use the substitution. U is equal to x plus 3. Then you've got du is equal to dx. And then you over here it will become 1 over root 2, and then you've got 1 over square root of u squared minus 9, and then du, and then you could see that it's straight away arccos u over 3 plus c, but with u being x plus 3, you may do that x plus 3 over 3 at C at the end. So I did it without this because it's a linear bracket. So, but if you go for substitution, so the awkward part in here was substituted by U, and then you can clearly see the formula. Okay, finally, we're going to move on to example 33. This time, oh, lucky us, they gave us the substitution. It's always nice when they do that. So I'll refer to this list in a minute if I need it. But at the moment, oh, it looks a bit strange, quite a big substitution. So you probably would find it difficult to come up with by yourself. So what I'm going to do, I'm going to first of all, whenever the substitution is given, just differentiate it first. So dx du is equal to a half, 3 goes to 0, and cosh goes to 4 sinh u, which is 2 sinh u du can replace dx. Okay, so let's actually work on this substitution. 4x squared minus 12x minus 7. So it's 4 times a quarter times 3 plus 4 cosh u squared. So I've squared my half straight away. Minus 12 times a half, 3 plus 4 cosh u. And then you've got minus 7. Let's see what we get here. So multiplying this out, the 4 and a quarter were cancelled. Then you've got 9 plus 12, 24 cosh u, add 16 cosh squared u, minus this will cancel to give you 6. 6 times 3 is 18, and minus 24 cosh u minus 7. Okay, so you've got 24 and minus 24, that's perfect. Then you've got 9 minus 18, so it's minus 9, minus 7 is minus 16, and you've got 16, so you've got 16 cosh squared u minus 16. So you know that cosh squared minus sinh squared is equal to 1, and cosh squared is sinh squared minus 1. Oh, yeah, let's do that. So it's 16 sinh squared. I should have noticed that if I did sinh squared, it's cosh squared minus 1. I've got 16 of these, that's fine. Although, minus 1 minus that should be plus 1, by the way. So we've got 16 sinh squared u, and you've got 16 minus 16, that cancels. So this is the replacement for the denominator. So our integral becomes 1 dx, so it's 1 over square root of 16 sinh squared u times dx is 2 sinh u. So this is 4 sinh u. When you square root it, that cancels with that. You've got 1 and 2 left. So it's an integral of a half du, which is a half u. Now a half u, oh, what is u? Well, that's good. Let's just prepare ourselves to replace it with u. Let's do it over here. Multiplied, we need to get to cosh u first. So 2x, we'll take 3 away. 1 divided by 4. This is going to be our cosh u. So u is going to be r cosh 2x minus 3 over 4. So we've got half r cosh 2x minus 3 over 4 plus c. Perfect. Okay, please take care and do every question in the exercise 6e very carefully, and then move on to next exercise. So take your time with these and ask for help. on anything you don't understand. Okay.